Okay, so let's start the FRQ. We see that there's a chart on the top, and we see that we're given x values where there's also f of x, f prime of x, g of x, and g prime of x. This shows that we're probably going to do some type of derivative problem because of these primes, and also that the function that we're going to be looking at will probably be some type of composite function. So let's look at the question. The functions f and g are differentiable for all real numbers, and g is strictly increasing. The table above gives values of functions and their first derivative as selective values of x. The function h is given by h of x is equal to f of g of x minus 6. So let's look at part A. Explain why there must be a value r for 1 is less than r is less than 3 such that h of r is equal to negative 5. So we're going to be, just based off of what it looks like, this question, we're going to be using some type of theorem. So what we're going to do first is try to define the endpoints of 1 and 3, the y values of the endpoints of 1 and 3, just because we have a y value here, negative 5. So we have h of 1, and that's just equal to f of g of 1, the function's right here, minus 6. And that's equal to, we have to look at the g of 1, so g of 1 is 2, so f of 2 minus 6. F of 2 is equal to 9, and we get 3. Now we have to look at h of 3, which is the other endpoint. So f of g of 3 minus 6. G of 3 seems to be 4, so f of 4 minus 6. And then we have f of 4 is equal to negative 1. So negative 1 minus 6 is negative 7. So our y interval will be from 3 to negative 7. Now we have to kind of choose a theorem to kind of prove that h of r can equal negative 5. So a theorem we want to prove is that the function, our unknown function, we don't have it drawn, will hit negative 5 at some point. And the theorem that we're going to use is called IVT. IVT is also called the intermediate value theorem, but you can always use its initials, and everybody will understand what it is. So here's a picture describing the IVT. We have h of 1 is equal to 3 and h of 7. H of 3 is equal to negative 7, and we don't know what the function looks like, so we can guess what it is. But what the IVT says is that if it's applicable, we can say that if between the y ranges will hit all y values. So the three things that the College Board needs to see so that you can prove IVT is, one, that the value right here, h of r, is in between the values of the endpoints, which it is. H of 3 is less than negative 5, which is less than h of 1, or negative 7 is less than negative 5, which is less than 3. The second thing we need to show is that h is continuous on the interval from 1 to 3. And we know this because it says right here the functions f and g are differentiable, which also means that f and g are continuous, and because h is a composite function of f and g, it is also continuous. So we know that h is continuous on the interval from 1 to 3 because f and g are. The third thing we need to show is that we just need to explain what we're proving. So by IVT, which is the theorem, there is an r value between 1 and 3 right here, where h of r is negative 5. And that's all you have to say to prove this.